Hello, friends. Welcome to another session. I am Orko. What we do here is primarily talking about different topics in quant, which is relevant for your CAT, NMAT, SNAP, IFT kind of exam, which is MBA entrance exams out of India. So, what we are going to do today is special equation problem session 2. So if you have not seen the previous session, which is on problem level 1, this is going to be a little advanced level problem. So please go through that video. I'll put that in the I button or in the description box. So that should be your first step, and then we'll come to special equation. Now, what is special equation? I'll just quickly recap. We did a topic on simple linear equation where we solve, let's say, equal to the number of variable. You will have equal number of equation, and from there you will be able to solve those problems. Most of the problems will be like that, but in simple linear equation. But when it comes to CAT or any other entrance exams, problem tends to be a little tricky. So what I mean by tricky is you will have more variable but less equations based on certain conditions. You have to find out what are the possible solutions. Without condition, there will be n number of solutions, but with the condition, there may be a possibility that you may get one or two solutions or a certain number of solutions that the question is looking for. So that's when it becomes a special equation, when there you have less equation and more variables. So with that, let's get started. Again, the idea is you see a problem, pause the video, try to do it by yourself for a couple of minutes, and then if you are not able to solve the problem, come back and see the solution. If you can solve the problem, still come back and see whether you have done it right or whether there is a different approach that we have taken. Okay, so let's get started with the first problem right away. So it says, and these problems are very common when it comes to CAT or any other entrance exams. These are absolute favorite of CAT. So it says the total number of marble with Bimala and Kamala is more than 85 but less than 100. So that means, can I say 85 less than Bimala plus Kamala less than 100? Bimala said to Kamala, if I give you some marble, I will have 5 times as you will have right now. So can I say 85? Let's say Vimala has X, Kamala has Y, because X and Y are our favorite variables. So let's convert that to X and Y. And then with X and Y, if you see, let's say Vimala to Kamala, there are n marbles. When Vimala said to Kamala, if you give me some marbles, or if Kamala is given to Vimala, let's say there are n marbles, because it says if you give me some marble, I will have 5 times as you will have. Instead, I give you the same number of marbles. So the marble getting exchanged is the same. So that means it is, let's say, n. So in the first condition, it says Vimala is saying, Kamala, if you give me some marble, I will have 5 times as many as you will have. So let's say Kamala giving Vimala n marble. So y minus n into 5 will become x plus n. So this is my equation 1. Then the second equation says, if I give you the same number of marble, I'll have 3 times more. So that means now if Kamala is giving Vimala, then Vimala will have y plus n. That will be multiplied of 3 with that will be the new marble that is left with Kamala, or sorry, Vimala. So x minus n. Right? So this is equation 2. So from here, we can definitely say x is going to be greater than y, because even after giving certain marble from x, it is 3 times more than y. Instead, I will have just find the difference between the number of marbles they have. So these are the 2 equations you have, right? So you have x plus n is equal to 5y minus 5n. So from here, I can say x minus 5y is equal to minus 6n. And from the second equation, I can say that x minus n is typically 3y plus 3n. Or from here, I can say x minus 3y is equal to 4n. Right? So both are equivalent to n. So if I just equate, can I write x minus 5y by minus 6 is equal to x minus 3y by 4, because both are equal to n. So from this one, I get this. and from this one I get this. Right now, if I just cross multiply 4x minus 20y is equal to minus 6x plus 18y, or I just take 10x is equal to 38y, or it gives me 5x is equal to 19y. Right? So 5x is equal to 19 times of y. So this is what they have been given to us. Now find the difference between the number of marble that they will have. Okay, so 5 times of x is equal to 19 times of y. So let's see what are the possible solutions of x and y. So 5x equal to 19y, there is no common solution. So the first solution is possible if I put x with a multiple of 19. The first multiple of 19 is 19. So x as a multiple of 19, just give me a minute. So x as a multiple of 19, and then you have y will, then 5x becomes 95, then y has to be 5. So this is the first one. The next set of multiples, so basically what I'm trying to say, since there is no common factor between 5 and 19, we are trying to say that x has to be first multiple of 19, y has to be first multiple of 5. That's the starting point. Because both of them has to be integer and none of them can be a negative number. Then the next one is x has to be 38, y has to be 10. And the next number is typically x has to be 57, y has to be 30. Then next number, the next number, x has to be 76, y has to be 40, and so on. But here the sum is 24, 48, your 87, this is 116. So obviously this is the only criteria that falls between 85 and 100. So what is the difference between, so 57 and 30 is your answer. So my answer is going to be x is equal to 57, or Vimala will have 57 and Kamala will have 30. The difference will be of 27. So 27 is my answer. Okay, so understood, because if we go above 57 and 30, it will be more than 100, which is not a feasible solution. So based on the condition, I'm trying to optimize the solution. Okay, if it is clear, please, it's fine. If it is not clear, you need a little more clarity, please feel free to drop a note in the description box, or drop me a mail in the mail ID given below. We can take it from there. So this is about it. So let's move on. Okay. Now let's say Suresh purchased stamps of 3 denomination, 5, 3, and 2. And he spends, so let's say 5 denomination ka, let's say x, 3 denomination ka, let's say y, and 2 denomination ka, let's say z. He spent a total 100 rupees purchase and at least 9 stamp of each of them. So since at least 9 stamps, na, you can make 5 denomination ka x plus 9, 3 denomination ka y plus 9, and z denomination ka z plus 9, because these are minimum. So by adding plus 9, what I'm trying to do is, they said how many could he have purchased, in how many ways he could have purchased. So then I will focus on x, y, z by taking out the mandatory 9 ones, right? So it will help me to solve the problem rather than doing x, y, z, because then I have to consider x, y, z will start from 9. By factoring 9 at the beginning, what I'm trying to do is I'm trying to optimize the equation based on x, y, z only, because the mandatory 9s are already taken care by doing x plus 9. So when I write the equation, you will be able to understand. So then my equation becomes 5 into x plus 9 plus 3 into y plus 9 plus 2 into z plus 9. This is equal to 100. Now, if I would not have taken the 9s and just taken x, y, z, then to optimize x, y, z, I have to first consider their minimum values are 9. Instead of doing that, I have added the 9 in the equation already, and then I will just optimize for x, y, z without having to think of any consideration of minimum 9, maximum something. Let's say 5x plus 45 3y plus 27, 2z plus 18, and this is equal to 100. So can I say 5x plus 3y plus 2z is equal to 100 minus 45 minus 27 minus 18. So 45 and 18 is 63, 90, so 10. So I can write 5x plus 2z equal to 10. Now all of them has to be a positive number or non-zero number. Non-negative numbers. So let's say x, y, z. So these are the three possible values that can take. So always when you have an equation like this, three variable, one equation kind of a scenario, always try to see which has the highest coefficient. So look for highest coefficient. So highest coefficient is of x. So I can say, which is 5. So I can say at max, x can take 2. X cannot take more than 2 because then yz has to have negative number, which is not possible. So x at max can be 2. That time y and z will be 0. Similarly, x can be 1 also. If x is 1, your 3y plus 2z become 5. 3y plus 2z become 5. So that way, it's only possibility that y takes 1 and z takes 1, right? That's the only possibility. Y takes 1 and z take 1. Is there any other possibility that y cannot take, even if y takes 0, z will not be a whole integer. If y takes 2, then it becomes more than 6. Even z is 1 that we have taken, z 0, y will not be an integer, z 2, y will not be an integer, z 3, it more than 6. So the only possibility is 1, 1, 1. Now let's say x can also be 0. X cannot be less than 0, so x can minimum be 0. So then your 3y plus 2z becomes 10. You are not able to see, just a minute. So then what we are trying to do is, let's say, if x is 0, then it will become 3y plus 2z equal to 10. Now there is a possibility that I can give y 0 and z 5 directly. That's a possibility. Or else, if you recall how to find out the next set of solution, if y equal to 0 and z equal to 5 is one solution, the next one is y should increase by the coefficient of z. Y should increase by the coefficient of z, and z should decrease by coefficient of y. So z has to be 2. Then again, if I increase y by coefficient of z, it will become 4. Z will become minus 1, which is not a possibility. So 2, 2 is another possibility. If you can't recall how we are doing this, increasing by coefficient of the other variable, you should refer to the first session of the special equation, where we have explicitly explained how sum of one equation, or where the sum are between two variables. So here 3y and 2z are two variables and one equation. And when you are only looking for positive or negative integral solutions, then you first find out a basic solution, which is 0 and 5 in this case, and then the next set of integer solution will be by increasing one and decreasing the other. So this is one way, but in depth, if you have to understand, please refer to the previous session where we have talked about in detail how to solve two variable one equation and find out the integral solutions of that. So with that, we can say there are 4 solutions possible. Actual numbers of x, y, z will be, actual number of 5, 3, 2 will be adding 9 to each of them. So since they have minimum 9, so if you actual numbers are x plus 9, so when we say 200, it is actually 1199. And so there are 4 ways you can find out. So 4 is your answer. Okay. To the next problem. Any difficulty, please feel free to drop a comment or a mail. But please try it by yourself first. Don't jump into the answer by seeing the solution right away. So try yourself for a couple of minutes, 3 minutes at least. Then if you are not able to solve, come back. If you able to solve also, come back and see whether you have done it right or is there a better approach on V and me. So then the next one is, if x and y are two-digit number, what is the least possible value of y that satisfies the equation? So again, one equation, two variable, and you have one condition, that is x and y are two-digit number. You have to find out y minimum, right? 4x minus 7y equal to 57. Okay, so one way you can do it is x and y. First, look for a basic solution. For x and 7y 57. So if I do, what are the solution? Okay, now if I think of y as 3, if I think of y as 3, then no, it's not coming. Okay, so let's do it in a different way. You can think for a basic solution to start with, but if it is not directly giving you the answer right away, so one of that I can think is, you may have to think a little for finding out the first solution. So let's say x is 2, so then 4x becomes 8, and so 4x minus 7y is 57. If x is 2, this becomes 8 minus 7y is 57, and then minus 7y becomes 49. So y becomes minus 7, right? So this is the first one. And then if there is a difference, then x should increase and y should also increase so that the difference remains same. And how much they should increase or decrease? They should increase or decrease by coefficient of the other variable. So since both are two-digit number, I have to look for a positive two-digit number of y. So I have to increase these two variables so that from minus 7, y starts increasing and reach that. So the next set of y, just reduce a little. So the next set of y will be increasing by coefficient of x, so that is minus 3, and x should be increasing by coefficient of y, that is 9. So 9 are 36 and 21, right? Then the next set of variable, x should also increase by coefficient of y, and this becomes 1. So 64 minus 7, 57. Then again, y is still not two-digit, so then y has to be 5. Then the next one, y has to be 9. Then the next one, y has to be 13. So this is the first value of y, where y will be 13 and this will be 16. 16 plus 7, 23. 3 plus 7, 30, 37. So x is 37. There is the least possible value of y. Least possible value of y is 13, which will satisfy the equation. So this is one way of solving, but you may need to spend some time to figure out the first value of 2 and minus 7. And from there, you can pivot on x should increase by coefficient of y should increase by coefficient of x. Since this is a difference, both of them should move in the same direction. And then from this way, do till you find the first two-digit value of y, that is the least possible. The other way you can do it is 4x equal to 7y plus 57, and then you can write 7y is equal to 4x, or not doing this, so let's keep it simple. So we can write 4x is equal to 4y plus 3y, just trying to break it in the multiple of 4, because the left side is a multiple of 4. So 57 ka closest multiple of 4 is 56 plus 1. So we can write 4x is equal to 4y plus 56, which is multiple of 4. And then we have to write 3y plus 1. So if I do x is y plus 14, because if I divide the first two by 4, and the next one is 3y plus 1 by 4. So in order to be an integer number, because x is a two-digit number, so it's an integer. So in order to become an integer number, 3y plus 1 by 4 has to be an integer, or 3y plus 1 by 4 has to be divisible by 4. So, or I can write 3y plus 1 has to be divisible by 4, not this. 3y plus 1 has to be divisible by 4. So then you start looking for the minimum value of y. If it is a 2-digit number, is 11, right? Or 10 you can think of. So 3 into 10 plus 1 is a 31, not divisible by 4. 3 into 11 plus 1, 34, not divisible by 4. 3 into 12 plus 1, 37, not divisible by 4. 3 into 13 plus 1, 40, divisible by 4. So the minimum is 13. So this is another way of doing it. Whichever way you are comfortable, you can follow this approach, or you can follow this approach. So these are both the ways you can do when there are one equation and two variable kind of a scenario. How many integral solutions are there for 9x square minus y square equal to 440? Let's see, 9x square, so y square is equal to 440, or we can write 3x plus y, 3x minus y is equal to 440. Now 440 typically means 2 cube into 5 into 11. So can I write total factors are your 3 plus 1, 1 plus 1. Again, if you are not sure how we are calculating total factors like this, every number needs to be prime factorized. And after prime factorization, if we take the powers of the prime factorization and add to 1 and multiply, we'll get the total number of factors. Again, something we have did in depth in the previous session. So please refer to the previous session where we have find out how to find out the total number of factors. So total number of factors are 16, right? If there are total 16 number of factors, if there are total 16 number of factors, 16 factors, so there are 8 ways. There are 8 ways to write. There are 8 ways to write, which is 8 ways to write. As a product of two numbers. So for example, again, I'm repeating, but if I've done the previous session, you absolutely can understand. If let's say 12 has how many factors? So 12, if I do 2 square into 3, so 2 plus 1 into 1 plus 1. So this 2 plus 1, this 1 plus 1. So there are 6 factors of 12. What are the 6 factors of 12? 1 into 12, 2 into 6, 3 into 4. These are the 6 factors of 12. So if there are 6 factors of 12, there are 3 ways you can write that it is a product of two numbers, right? So 12 has 6 factors, 1, 2, 3, 6, 4, 12. So there are 3 ways you can write it as a product of two number. So there are 8 ways you can write that this is a product of two number. Now the only catch here is they have not mentioned whether it's a positive or negative number. So there will be negative values as well. So 8 ways to write as a product of two number when you consider only positive number. Then similar 8 ways for negative factors. So total is 16 ways. So what I mean by this is, like you have written here, similarly minus 1 into minus 12 is also a factor. Minus 2 into minus 6 can also be written. Minus 3 into minus 4 can also be written. So there are total 16 ways, because you see 12 has 6 factors. 12 has 6 factors, right? So in that way, 3 ways we can write if we consider only positive factors. Similarly, 3 ways we can write if we consider negative factors. Since there is no positive or negative has been said here. It says just an integral solution. So we have to consider both positive and negative. So like we got 440 has 16 factors. So there are 8 ways to write it as a product of two numbers. Similarly, there will be 8 ways to write it as a product of negative numbers as well. Please refer to the previous session. Again, I'm repeating, if you have any difficulty in understanding the way to find out the multiple factors, but I hope it will be clear. Still, if it is not clear, please drop a comment note in the comment section or drop me an mail. We can take from there. Soumya purchased some samosa sandwich puff by spending 219, and the costs are given, at least 3 of them. Okay, then we follow the same approach. So let's say samosa x plus 3, sandwich y plus 3, and puff let's say z plus 3. Again, since there are 3 are the minimum number, we have started with that. Maximum number of sandwich he could have purchased. So that means you have to find out y max. Y plus 3 is the number of sandwich. If I find out y max, y plus 3 will anyway be maximum. So the condition is samosa sandwich puff was 10, 15, 18. So 10 into x plus 3 plus 15 into y plus 3 plus 18 into z plus 3 is equal to 219. That's been given. So I can write 10x plus 30 plus 15y plus 45 plus 18z plus 54 is 219. Or I can write 10x plus 15y plus 18z is equal to 219 minus 30 minus 45 minus 54. So all of these will be added. And this is 219 minus 9, 7 plus 129. So this is 90. Right? So 10x plus 15y plus 18z is 90. Okay. So with that, I know 10x plus 15y plus 18z is 90. So do the same approach that we did in the previous session. So x, y, and z, right? So they said y has to be maximum. Y has to be maximum. What is the y coefficient is 15. So y can maximum take 6. In that case, both will be 0. So this is the maximum possible value of y. So that means y max has to be 6 plus 3, 9, 9 sandwiches. The maximum can get 9 sandwiches. So y plus 3 max to be 6 plus 3, 9. 9 should be your answer. It's clear. The same approach we have did earlier. The maximum value of any variable will be when the others are 0. And we can make them 0 because we already added 3. So basically, when we say y sandwich maximum, sandwich will be of 9. X0 means samosas will be of 3. Puff Z0 means puffs will be of 3. So minimum 3s are there, but you have 9 sandwiches, 3 samosas, 3 puffs, which will satisfy the condition of at least 3. Also make sandwiches maximum. The last problem for today. Charan takes up an assignment for a month at a craft village where he is expected to make a piece of pottery every day. Okay. And for every defective part, he paid 80. For every non-defective part, he paid, find the number of defective parts that made. Okay. Find the number for every defective part. Okay. Let's say defective is X and non-defective is Y. So we paid 80 for every non-defective part, he pays back 28. So that means non-defective for every defective part, he pays back 28. So can I write 80y minus 28x is equal to 1752. 80y because of 80 non-defective part, y non-defective part, he got 80 into y rupees. For x defective part, he paid back 28 into x rupees. So 80y minus 28x is what is he paid at the end. So if I divide by 4, it will become 20y minus 7x, 438. 438 . 438 . 438 . 438 . 438 . 438 . 438 . 438 . 438 . 438 . 438 . 438 . 438 . 438 . 438 . 438 . 438 . 438 . 438 . 438 . 438 . 438 . 438 . 438 . 438 . 438 . 438 . 438 . 438 . 438 . 438 . 438 . 438 . 438 . 438 . 438 . 438 . 438 . 438 . 438 . 438 . 438 . 438 . 438 . 438 . 438 . 438 . 438 . 438 . 438 . 438 . 438 . 438 . 438 . 438 . 438 . 438 . 438 . 438 . 438 . 438 . 438 . 438 . 438 . 438 . 438 . 438 . 438 . 438 . 438 . 438 . 438 . 438 . 438 . 438 . 438 . Yeah, 20y minus 7x is 438. It can't be simplified any further. Find the number of defective parts that he has made. Again, we start with the simple one. So let's say, okay, let's do it by the division approach. Okay. Okay. Instead of starting to find out the first minimum solution and try to maximize from there, let's see what we can do in a other approach that we talked in the previous, where we have two variable one equation by making it a multiple must be divisible by a number. Let's try to do it that way. So 20y, I can write 20y 438 plus 7x. So 20y, I can write 440 plus 7x minus 2. Why I write 440? Because that's a multiple of 20. So y becomes 22 plus 7x minus 2 by 20. Now I know x and y has to be an integer number. So y has to be an integer when 7x minus 2 must be divisible by 20. 7x minus 2 has to be divisible by 20, right? So what are the ways? So what are the values of x can be? So if 7x minus 2 has to be divisible by 20, you can easily think of what is the value of x. X value, it has to be 3, 4, so 20. So 7x minus 2. So 20, first multiple of 7x minus 2 is 20 only. First 20th multiple of 7x minus 2 has to be 20. In that case, I can see x cannot be an integer because 7x becomes 22. X is not an integer. So 7x minus 2 can be 40 next. If it is 40, then 7x becomes 42 and x becomes 6. So x becoming 6. Now, if x is becoming 6, what is the other solution? The other solution is y is equal to, if it is 6, so 7, 6 are 42. I'm just putting it in this equation. So this is 22 plus 42 minus 2 by 20, or you can say 24. So x is 6, y is 24, right? X is 6, y is 24. The next solution, x has to be increased by 20. Otherwise, it will not be a multiple of 20, right? So it has to be increased by 20. So this will become 26 and y has to become 31. So if you calculate by putting x equal to 26, you will get y as 31. So this, and then it will go on. But if you see typically, the main catch of the problem is this line for a month. So if someone is doing for a month and takes up an assignment for a month to make a piece every day, you expect to make a piece of pottery every day. A piece of pottery every day, a month, maximum can be 31. If you make one piece for a month, you maximum can make 31. So can I write this x plus y? This is the main catch. Maximum is 31. So then this has to be the solution. It cannot have any other solution because the further you go, the sum will increase and it will be on 31. So that's about it. So the answer is find the number of defective pieces he has made. Defective is x. So the number of defective pieces is 6. Okay. So I hope it's clear. And we had a good session. I hope you understood certain problems. You learned something new on certain approaches of different type of special equation problem. So if you can go through the previous session and today's session and you solve some other problem at home, if you feel any doubt, any problem, please feel free to drop a mail. I will be able to guide you from there. The mail ID is in the description box. and hope you like the videos. Then if you are with me till now, please like, share, subscribe, and share it with others. It motivates me to create certain contents like this, and hopefully I'll be able to provide more and more value to you. So thank you. See you next time. Have a good day. Bye.